Okay, get ready, because we're going to take a deep dive into this physics paper that's making some pretty big claims.
Yeah, it's definitely causing a stir.
Tackling the fine structure, constant, alpha,
Right, alpha.
that mysterious number around 1137.
Yeah,
That seems to pop up in electromagnetism everywhere.
it's everywhere.
And this paper's suggesting that we might finally understand why alpha has that value that it does.
Yeah, it's exciting stuff.
So what's their approach? What are they doing that's different?
Well, it's certainly shaking things up in the physics world
Okay.
because they're taking a route that's pretty different from the mainstream.
Yeah.
They're suggesting that alpha isn't just some random number,
Right.
but it comes directly from the geometry of waves. Specifically, how they behave in systems that are kind of like fluids.
Interesting. So like waves in water.
Yeah,
That
something like that.
Okay.
You can think of it that way.
So that's fascinating.
Yeah.
And this is where it gets really interesting, especially for a technically minded audience like you folks.
Right.
The paper relies on the Lorentz Ether Theory, LET,
Yep.
which has been kind of pushed aside in modern physics.
It's not really talked about much these days.
Yeah, so they're going back to that,
Yeah.
and they're suggesting that the medium itself,
This ether.
this ether, actually influences how matter behaves. And that's what leads to the apparent constancy of the speed of light.
Yeah, it's not that they're dismissing relativistic effects.
Oh, okay.
They acknowledge that things like length contraction and time dilation, they're real.
Uh-huh.
The difference is in how they interpret it. They're suggesting that these effects are a direct consequence of matter interacting with this ether.
Right.
Not simply like inherent properties of space-time, as Einstein's relativity suggests.
So they're looking at the same data, but through a different lens.
Exactly.
And that allows them to connect the dots in a way that leads to alpha.
Precisely.
Okay, I'm starting to get it, but before we just toss this aside as some fringe theory,
Yeah.
it's worth remembering that even John Bell, who's famous for Bell's theorem,
Right, a giant in the field.
he acknowledged that while Einstein's approach is elegant,
It is very elegant.
exploring the path laid out by LET proponents like Fitzgerald, Larmor, Lorentz, and Poincaré,
Quite a lineup.
it can offer a deeper understanding of the underlying physics.
It's about challenging those deep-seated assumptions,
Right?
and seeing if a fresh perspective can yield new insights.
So how do they actually make this connection? Where do they start with this whole idea?
Well, to grasp their logic, we need to start with wave mechanics,
Okay.
the heart of their argument.
Right, wave mechanics.
They focus on how waves act in systems that are fluid-like, particularly near vortices.
Vortices, those are those swirling patterns you see in fluids, right?
Exactly,
Right.
like whirlpools or the swirls in your coffee.
Okay.
They talk about this concept called wave closure,
Wave closure.
which basically means for a wave to create a stable, repeating pattern,
Okay.
especially around a vortex. It needs to perfectly align with itself after completing a full loop.
So it's got to meet up perfectly with its starting point after going all the way around.
Yeah, like if the wave doesn't align after going full circle,
Uh-huh.
it just kind of dissolves into chaos.
Mhm.
But when it does line up perfectly,
Yeah.
you get this self-reinforcing structure, a stable wave.
Interesting.
And this has really important consequences, especially when a vortex is involved.
I see. And that's where alpha comes in.
That's where it all ties together. These
Yeah.
geometric rules,
Right.
coupled with how the energies spread out in the wave, they lead to very specific relationships between physical quantities.
Okay.
And the paper argues that there's only one very specific value for alpha that satisfies all these conditions simultaneously. They're saying alpha isn't just a number we measured.
Right.
It's the only number that fits when you consider how waves must behave in 3 dimensions.
Yeah, it's like the universe is saying, hey, if you want stable wave patterns, this is what you got to work with.
That's a great way to put it.
Okay, so to really understand this, we need to get into the nitty-gritty.
The details.
Yeah, the details.
They start with the basics.
Okay.
Wave speed, how fast it travels,
Right.
and phase.
Which describes how it oscillates, right?
Exactly. Okay. They point out that the wave's phase has to have a definite value at every point in space and time.
No ambiguity.
No ambiguity.
Okay.
And this is where their reliance on LET becomes really crucial.
Okay, how so?
Having a medium, the ether, gives a reference frame for these waves.
Uh-huh.
So they can talk about absolute motion through that medium
Okay.
and how that affects the wave's phase.
I see. So the ether provides the context for understanding how these waves behave.
Exactly.
Right, then what?
They then dig into the energy carried by the wave,
Okay.
highlighting it's got two parts.
Okay.
Kinetic energy from the motion of the medium,
Right.
and potential energy from the medium being distorted by the wave itself.
Okay.
And the balance between those two becomes the key part of their argument.
So how do vortices actually modify the properties of this medium, this ether?
It's like when you stir a thick soup.
Okay, I like where this is going.
The swirling motion actually changes the soup itself.
Okay.
The vortex adds its own energy to the system
Uh-huh.
and changes how the medium behaves.
So the vortex is not just moving the soup around.
Right.
It's actually changing the soup itself.
Exactly.
Okay.
And this particularly affects the wave speed near the vortex.
So they're saying the vortex, through its swirling, actually changes how fast waves travel nearby.
Exactly.
Wow.
They've even derived a mathematical equation for this wave speed modification,
Okay.
demonstrating that it decreases as you get closer to the vortex.
So the closer you get to the vortex,
Yeah.
the slower the waves travel.
Exactly.
Interesting. And this modification is due to a combination of things, right?
Yeah, it's a combination of the swirling motion itself
Right.
and the vortex's effect on the medium's elasticity.
So it's like that spinning bicycle wheel analogy,
Good analogy.
where the spinning makes the wheel feel more rigid.
Exactly. The vortex's rotation changes the pressure in the medium,
Mhm.
affecting its elasticity and further modifying the wave speed.
Well, they've really thought this through.
They have.
They even have numerical simulations to back it up.
They do, and they validate this relationship with remarkable precision.
Okay, so we've got these waves, we've got vortices, we've got this wave speed modification.
All the ingredients.
But how does all of this lead back to alpha?
That's where things get even more fascinating.
Okay, I am hooked. Tell me more.
The paper analyzes how energy is distributed near the vortex
Okay.
and points out a very specific ratio between kinetic and potential energy
Right?
at a particular distance from the vortex core.
Mm-hmm.
They call this distance the quantum radius,
Quantum radius.
and it's directly related to alpha.
Hold on. Are you saying that the ratio of these energies at this specific distance linked to alpha
Yes,
is what determines the value of alpha itself?
you got it.
That's pretty mind-blowing.
It is.
So alpha isn't just some arbitrary number we stumbled upon.
No.
It's a necessity dictated by how this whole system works.
Precisely. It emerges as a necessity,
Wow.
dictated by the wave's need to stay stable as it interacts with the vortex and the surrounding medium.
That's a really elegant idea.
It is.
But what about their claim that alpha is also encoded in the phase of the wave?
Right, that's another crucial piece.
How does that fit in?
They show that at twice the quantum radius,
Okay.
the phase of the wave,
Right.
when you express it in units of 2 pi,
A full cycle of the wave.
exactly, is
Okay.
exactly equal to negative alpha.
So alpha is showing up in both the energy distribution and the phase of the wave
Yes.
at these specific locations
Yes.
related to this quantum radius.
That's like a hidden code.
It is. It's like a hidden code embedded in the structure of the wave.
That's a great way to think about it.
So it's not just a coincidence,
It's
this
just-
phase relationship.
It's essential for the wave to stay stable, to maintain that self-reinforcing pattern. Right.
If the phase were any different,
Uh-huh.
the whole thing would fall apart.
Okay, so we've got these two seemingly separate relationships,
Yeah,
both pointing to the same value for alpha.
right.
But how do they use this information to mathematically derive the actual value?
They bring it all together with that wave closure concept we mentioned earlier.
Right, like fitting the pieces of a puzzle together.
Exactly.
Okay.
They show that this wave closure condition,
Uh-huh.
combined with the energy ratio at the quantum radius
Right.
and the phase relationship at twice the quantum radius,
Yeah.
it forms a closed set of equations.
Closed, meaning there's only one possible solution.
Precisely.
Okay.
And when they solve those equations,
Uh-huh.
the only value for alpha that satisfies all those conditions
Yeah.
is the value we actually observe in nature,
They're not just getting close.
Hmm.
They're getting it exactly right.
to all known decimal places.
That's remarkable.
It is pretty remarkable. So they're not just saying alpha is a number we measure. They're saying it's fundamentally determined by the geometry of space
Yeah.
and how waves work in this medium.
Exactly.
All right, so far we've been focusing on the theoretical framework and the math behind it.
The foundation of their argument?
Yeah, but I'm sure people are wondering, how does this connect to the real world?
That's a great question.
What's the experimental evidence for all of this?
Well, that's what we'll dig into in part 2.
All right, we'll pick it up there.
Sounds good. Picking up where we left off, you might be thinking, hold on, isn't the Lorentz ether theory a bit outdated?
Yeah.
You know, didn't Einstein's special relativity kind of put that to rest?
That's a really good question.
Yeah.
And I'm sure a lot of physicists would be thinking the same thing.
Absolutely.
So how would they respond to that?
Well, this paper argues that the story of LET is more nuanced than we might think.
Okay.
They point out that the original LET
Yeah.
wasn't actually trying to say that the speed of light is a universal constant
Right.
in like an absolute sense.
Yeah.
Okay. It was more about how light behaves within a medium.
Within this ether.
Yeah, the
Yeah.
ether.
Right.
And how objects moving through this medium interact with it.
Okay.
So the idea was that the speed of light appears constant
Right.
because of how the ether influences both the measuring devices and the path of light itself.
So it's not about saying Einstein was wrong.
Yeah.
It's just suggesting there might be another way to interpret those observations.
Exactly, another lens to look through.
Okay.
And the authors argue that this alternative lens,
This LBT lens.
yeah, through LET, allows them to make connections that aren't so obvious through the standard interpretation of special relativity.
So it's about stepping off the beaten path and seeing if a less traveled road might lead to some new discoveries.
Exactly.
Okay, so we've established that their approach is grounded in LET.
At its core.
But I'm sure our listeners are eager to get into the math.
Yeah, let's get down to the nitty-gritty.
How do they actually go from these swirling vortices and wave speed changes to deriving the value of alpha?
Well, that's where their deep dive into the energetics of the system comes in.
Yeah.
Remember we talked about how the wave carries both kinetic and potential energy?
Right, the energy of motion and the energy stored in the distortion?
Exactly.
Okay.
They demonstrate that the ratio of these two energies takes on a very special value
Okay.
at a particular distance from the vortex core.
Okay.
They call this distance the quantum radius,
The quantum radius.
and it's directly linked to alpha.
Hold on. So you're saying that the ratio of these energies at this very specific distance
Yeah.
that's tied to alpha
Yes.
is what determines alpha itself?
That's exactly what they're arguing.
Wow, okay.
It's pretty amazing, right?
Yeah.
The paper argues that this specific energy ratio
Right.
is essential for the wave to remain stable.
Okay.
If it were any different, the
Mhm.
wave pattern would break down. It would lead to chaos instead of the order that we see in nature.
So in a sense, alpha has to have this value
Yeah.
for this whole system to work.
That's right. It's not just some random number.
Yeah.
It's a necessity dictated by the wave's interaction with the vortex
Okay.
and the medium around it.
So that's a pretty elegant idea.
It is.
But what about their claim that alpha is also encoded in the phase of the wave?
Right. That's another piece of the puzzle
Yeah.
that really strengthens their argument.
How does that fit into the picture?
They show that at twice the quantum radius, the
Right.
phase of the wave,
Right.
when it's expressed in units of 2 pi,
So a full cycle.
exactly,
Okay.
is equal to negative alpha.
So alpha is showing up in both the energy distribution and the phase of the wave at these specific locations related to the quantum radius.
It's like they've uncovered a hidden code.
It is. It's like a secret message embedded in the wave structure.
That's a great way to put it.
So is this just a coincidence?
No, they don't think so.
Okay.
They argue this phase relationship is crucial
Okay.
for the wave to maintain that stable, self-reinforcing pattern.
Right.
If the phase were any different,
Yeah.
the whole system would fall apart.
Okay, so we've got these two seemingly independent relationships,
Right. Two separate pieces of evidence.
both pointing to the same value for alpha.
Yeah, that's pretty compelling.
But how do they actually use this information
Okay.
to derive the value of alpha mathematically?
They bring it all together with that wave closure concept.
Right, like fitting the pieces of a puzzle.
Exactly.
Okay.
They demonstrate that this wave closure condition, combined with the energy ratio at the quantum radius
Right.
and the phase relationship at twice the quantum radius,
Okay.
forms a closed system of equations.
Closed, meaning there's only one solution.
That's right.
Okay.
And when they solve these equations,
Yeah.
the only value for alpha that works is the one we actually observe in nature.
So they're not just getting an approximation.
Nope.
They're getting the exact value.
To all known decimal places.
Wow.
It's pretty incredible.
So they're saying it's not just a number we measure.
Right.
It's determined by something deeper.
Yeah, the geometry of space
Right.
and the mechanics of how waves propagate.
So we've been talking a lot about the theoretical side,
The foundation.
but I'm sure everyone's wondering, where's the experimental evidence?
That's a great question.
How does this connect to the real world?
Well, that's where things get even more interesting.
Okay, lay it on me.
They point to this fascinating phenomenon known as superfluid helium.
Superfluid helium.
Okay, which basically behaves like a quantum fluid on macroscopic scales.
So a quantum fluid, but we can see it.
Exactly.
Okay, I'm intrigued, but how does that connect to this whole wave vortex theory?
Superfluid helium does some really weird stuff.
Okay.
At super low temperatures.
Uh-huh.
It can flow without any resistance.
No resistance, wow.
It can defy gravity.
Okay, this is getting strange.
And it exhibits other quantum effects. One of its most striking features is its ability to form what are called quantized vortices.
Quantized vortices, what does that even mean?
It means the vortices in superfluid helium can only exist with specific discrete values of rotation.
Okay.
They can't just spin at any random speed. They have to be multiples of a fundamental unit.
So they're quantized.
Yeah, just like energy levels in an atom.
Okay, so these quantized vortices are like real-world examples of the wave-vortex interaction.
Precisely. It's like seeing the theory come to life.
That's amazing.
And the paper argues that the wave speed modifications they derived actually manifest in superfluid helium.
Okay.
They predict that the speed of sound,
which is basically a wave traveling through the fluid.
Right. Will change in a very specific way near a quantized vortex.
So they're saying that superfluid helium provides a way to test their theory in a lab.
Exactly.
Have they actually observed these changes in the speed of sound?
The paper cites existing experimental data that seems to support their predictions, but they say more precise measurements are needed to really confirm this effect.
So it's like they've given us a treasure map.
A map to a scientific treasure.
And now it's up to experimental physicists
explorers
to go and see if the treasure's really there.
Exactly.
Yeah, I like it.
And they go even further.
Okay.
They suggest that superfluid helium could offer new ways to measure alpha.
Okay, how so?
They propose that by studying the energy ratios and phase relationships in superfluid helium, we might be able to get an independent measurement of alpha.
Wow.
Providing even more support for their framework.
Okay, so we've got this intriguing theoretical framework.
Right, the foundation.
A compelling mathematical derivation.
The nuts and bolts.
And a potential avenue for experimental verification.
Putting it to the test.
Where does the paper go from here?
Well, that's what we're going to dive into in part 3.
All right.
Exploring the mind-blowing possibilities this theory opens up.
Okay, like what?
From atomic structure to the nature of gravity itself.
I can't wait. Okay, so we've taken this deep dive into the theory behind this paper.
Yeah, we've really explored it.
Looked at the math and how it could potentially be tested.
It's a lot to take in.
But now I want to take a step back.
Okay.
And think about the bigger picture.
The implications.
Exactly. If alpha...
fundamental constant.
Right. This number that governs electromagnetism.
Yeah.
If it really does come from the geometry of space and the behavior of waves.
If.
It is a big if. But if it does, what does that tell us about the laws of physics as we understand them?
It raises a really profound question.
Yeah.
Are these laws that we've discovered really fundamental?
Right.
Or are they just a reflection of something deeper?
A more fundamental structure.
Exactly. A hidden code underlying everything.
It's like we've been so focused on the individual trees.
Right, the details.
That we've missed the forest.
A big picture.
Exactly. And this paper is urging us to look up and see that forest.
To see the grand design.
The underlying code that governs it all.
And that code, in this case, it could be rooted in wave mechanics and the geometry of space itself.
So instead of seeing these fundamental constants as just arbitrary numbers.
Just values we've measured.
Yeah. We might need to start thinking of them as emergent properties.
Arising from something deeper.
Right. From a more fundamental set of rules.
Embedded in the fabric of reality.
It's like they've opened this Pandora's box of possibilities.
A whole new way of looking at the universe.
Where everything is connected.
And governed by these elegant geometric rules.
It's a pretty mind-blowing concept.
It is.
And speaking of mind-blowing.
Yeah.
They even hint at the possibility of extending this framework to understand gravity.
That's a pretty ambitious leap.
It is, but gravity has always been this big mystery.
The odd one out.
Exactly. It's resisted all attempts to unify it with the other forces.
And any theory claiming to do so is going to face a lot of skepticism.
But even if their specific approach doesn't pan out, the idea itself is pretty amazing.
It's a beautiful idea.
To think that the same principles governing waves at the quantum level.
The very small.
could also be responsible for the large-scale structure of the universe.
It would be a testament to the interconnectedness of everything.
So what would be the ultimate test of this theory?
What would convince the skeptics?
Yeah, what evidence would we need?
Well, as we discussed, they've proposed some experimental tests.
Right, like with superfluid helium.
Exactly. If precise measurements of those quantized vortices confirm their predictions about how wave speed changes near them,
Yeah.
that would be a huge step towards validating their framework.
What about their suggestion that this could lead to new ways to measure alpha?
Right, more precise ways.
Yeah, is that realistic?
It's definitely an exciting possibility, if they're right.
Yeah.
Then studying the energy ratios and phase relationships in systems like superfluid helium could give us a much deeper understanding of how alpha relates to other fundamental constants.
And that could revolutionize our understanding of physics.
Potentially.
Well, we've covered a lot of ground today.
It's been a fascinating journey.
We've gone deep into this paper.
Deep dive indeed.
That's making some really bold claims.
Challenging the status quo.
And presenting a completely new perspective.
A fresh way of thinking.
On the nature of these fundamental constants.
These blocks of our universe.
And whether or not this particular theory stands the test of time.
Yeah.
It's a reminder that science is all about pushing the boundaries.
Questioning.
Exploring.
And never being afraid to think outside the box.
So until our next deep dive,
keep those minds curious.
Keep exploring.
And keep searching for those deeper truths.